Hi class, Mr. Morris here, and I was just going to do a quick video on states of matter. You probably have already seen these, and hopefully you already know just from looking at these pictures which state of matter each represents. Looking at the particles, if you were to zoom in and look at just individual atoms and molecules and how they're arranged in a solid, liquid, and gas, which would be which. So just kind of pause the video and try it yourself and identify what this is, and what this is. Hopefully you got that. This should be a solid. This one right here would be the liquid. This would be the gas. Now we'll talk about kind of the shape, the volume, some of the properties that we know about solids, liquids, and gases. I want to show you an animation to do this. So this is a good simulation for states of matter. You can see that this is the solid state of matter, and you can kind of see how they're arranged. They are close together as in the picture. There's kind of an orderly shape. They aren't holding completely still. They're vibrating around a little bit. They're staying pretty much in the same place, but they are vibrating in place. So if you look at your solid, what could we say about its shape? Well, it's not spreading out to change shape at all. It's got a very fixed or unchanging shape. So the word we would use here is definite, not indefinite. So it's a definite shape. You could just circle that if you're doing this on paper. Liquid. Let's change the state of matter. Okay, now I can see that the shape, as soon as I change to liquid, instead of it being all piled together like that in a fixed shape, the liquid took whatever shape the container had. Okay, so it has a variable shape or an indefinite shape. Gases. Okay, it definitely took the shape of the container. It's just filling it up. So the shape changed. It was indefinite. Think about the volume. Okay, the volume of each. Solid, the volume is fixed. It's not changing. Liquid. Well, I could pour this in a different container and it would still be the same volume. It would still be the same amount of liquid if I poured it in a different container. It might take a different shape, but the volume will be the same. Okay, and then look at the gas. That gas, it'll fill whatever container I put it in. Just to illustrate that, if you look at this, if I change the volume of the container, there's higher pressure and stuff. They're bouncing around more, but it takes whatever volume when you pour them in a different container. So two of them have a definite volume. And if it's a little confusing for you, just make sure you memorize it. This is one of the most missed questions. Liquids have a definite or fixed volume. Their volume does not change. The shape changes. The volume won't change when it goes from one container to another. Gases are the only state of matter that have an indefinite volume. They have indefinite shape and indefinite volume. They're the only one. Okay. When we're talking about the arrangement of particles, if we think back to the solid state of matter, they're arranged tightly together, right? They're packed tightly together. Okay. It's kind of orderly. Somewhat orderly at least. Now, what about liquids? So liquids, they're close together. They're loosely held, but close together. Okay. We could also say they're disorderly or random might be another word that you would choose to use here. Gases are different. If you look at the gases, so the liquids, they're close together, but they're kind of disorderly. Gases, they're even more disorderly. They're chaotic. They're all over the place. They're random. and spread out. Talking about the movement of the particles. Solids, we said they vibrate in place. If we're looking at the liquid, they're moving around a little bit more. They're actually moving past each other sometimes, so slide past each other. And if you look at the movement of gas particles, they're moving all over the place. It's random, it's crazy, it's chaotic. And they move more quickly from one place to the next. But I hope you notice that they actually move in straight lines until they hit each other. So it's random just because they're colliding with each other. So what we say is they move in rapid, random, straight line motion. All right, compressibility. So that goes back to the other animation. If I have a solid, which I don't have right now. Okay. If I have a solid, if I were to try to cram that down, I couldn't compress it. If I had a liquid, I can't compress it. Same. But if I have a gas, I can compress it. I can push it into a smaller space. It might have a high pressure, but I can actually move it into a smaller space. So solids are not compressible. Liquids are not compressible. Gases, we would say, are easily compressed or compressible. Easily compressible. All right, that's pretty well it for states of matter.